The structure of a fabric contributes to its tendency to shrink. More open structures have a greater propensity to shrink. A mechanical process, referred to as compaction, can be used to reduce fabric length shrinkage by mechanically forcing the structure of the fabric to compress itself. Yarns are flexible and during fabrication are bent into nonlinear configurations. In the case of knits, fabrication and processing tensions tend to elongate loops. If the shape of individual loops can be made more round, the fabric is made more compact, and the length can be reduced. Less washing shrinkage is a result of this process. In the case of woven fabric, more crimp is created in the warp yarn, which reduces its length. The more the crimp, the lower the shrinkage. When knits or wovens are compacted, the fabric becomes heavier and thicker, and the yardage is reduced. Softeners on the fabric and steam in the process will allow the yarns to more easily slip by each other and readjust themselves. There are two basic technologies for compaction. The first type is based on the heated roll and shoe principle. Steam is applied as fabric wraps around the heated feed roll, made of steel. Just enough moisture is applied so the fabric will move freely. The fabric moves between two heated shoes, which have special surfaces that grab the fabric in a controlled way. The gap between these shoes is set to achieve compaction. The delivery roll is made of rubber and turns at a slower surface speed than the feed roll, and along with the shoes, slows the fabric down to allow for compaction. When the fabric hits the surface of the heated shoe, the fabric slows, shortens, and compacts, based on the surface friction in the compaction zone. Overcompaction will result in a corrugated appearance. Note how the fabric coming out of this machine is slightly thicker than the fabric going in. A similar but different system design incorporates a compaction blade located below one heated shoe, positioned between the feed and delivery rolls. With this system, the compaction also takes place when the fabric movement is precisely slowed by surface contact in the compaction zone. A second kind of compaction, belt compaction, utilizes either a rubber or a felt belt that is stretched by flexing over a pressure roll. The fabric is laid on the belt while the belt is still stretched. Steam is applied as fabric enters the path where it is pressed between the belt and a palmer unit, which is heated. Compressive shrinkage of the fabric with the rubber belt is obtained by the recoil of the belt when it is flexed around the palmer unit. After the fabric has been compacted, it's preferred to flat fold the fabric because forming a roll can result in undesirable tension and stretch the fabric. After compaction, the fabric can go directly to cut and sew.